let's talk about problem 89 on page V. They don't have it labeled a think problem, but it definitely is. We have 7 pages to this solution. The first thing that we are asked to solve for is what is the current at A1. In other words, if we hooked up an ammeter right here, and so we're only looking at this resistance, this light bulb here, which is 12 watts. And we know that the power is 100, and not power, the voltage, the EMF, the voltage being pushed through the circuit is 120 volts. So with that, we have voltage, okay? We know that it's 12 watts, so I can plug in the 12 watts, divide by the 120 volts, and you will get a decimal number, okay? Get a decimal number for the amps. And that's at this one point right here. You're just measuring the current that's pushed through just this part of the cycle. This wire hooked up to this light, this resistance, and as it comes through over here, we measure the amps. Okay, so write that down as the amps for A1. Now, in a little bit, we're going to solve for the amps for A2. That's what it's asked for, but it's going to take a little more work to do that. So here we go. We solved for the amperage on this wire right here. We have that. Now we're being asked to solve for A2. Well, before we can do that, we have to figure out how many amps are coming through right here. Now that's not an exact question that we have to solve for, but we have to use that as an intermediate step before we can get to our final answer. So let's go through the same thing. We want to find the current right here by taking the power, which is 60 watts, and divide by the voltage, which is still 120, okay? So I want you to use your calculator, get a decimal answer, and write that down. That's not our final answer. That's not the answer for part B, but it's a step toward finding the answer. Okay, so do that math right now. Now, to find the current at A2, all right, which is right here, we need to find the voltage, which that's given, 120, but we have to find the total resistance. Now we know this resistance and we know this resistance. Well, actually we haven't solved for resistance. We just at this point have the watts. So we're going to have to solve to find the resistance of both of these. And then they're in parallel. Do you see that? One's right above the other. They're running parallel. It's not a series circuit. So we have to use that formula 1 over R equals 1 over R1 plus 1 over R2. So now we need to find R1 and R2 in ohms. Okay, that's resistance. So the first light bulb was the the voltage is 120, and R1 we solved already for that. We had 0.5 amps. So now, and that's the I. So now we can solve for the R. So basically we did V divided by I, top divided by bottom, equals R1. So what is R1? Let me get a pen marker here. So R1 is divide, okay? So take the top number, divide by the bottom number, write that number down as the number of ohms. Okay, go ahead and do that. Now let's figure out what the R2 value is. So we're going to take V, which is still 120 volts, divide by the current, which for this bulb is 0.1 amps. And we found that back for step 1 on A. So now take 120 and divide by 0.1 and write that answer here as the number of ohms. By the way, question C for this problem asks you what is the resistance for the second light bulb. So after you calculate this, you can write that answer down for C rather than coming back and recalculating it. All right, are you ready? We need to find the total resistance. So here's our formula. When they're in parallel, the total resistance is equal to 1 over R1 plus 1 over R2. So you should have gotten 240 for R1 and 1,200 for R2. Now use your calculator, and if you have the A, B, C button, you can put in 1 over 240 plus 1 over 1,200. And I want you to do that step. Okay, go ahead and do that and confirm that you get 1 over 200. If you get a decimal number like 0.05, that'll kind of work, okay? But this is better because what we're looking for is the reciprocal. So that just means flip this upside down and the 200 ends up on top, and that is your total resistance. We're still not done, okay? This is still an intermediate step. But now we know the total ohms is the 200. So write that step down somewhere on your paper. Are you ready? And now for the last step, yippee yippee. They want us to find the current at the ammeter reading of A2. So if you look back at the diagram in your PACE at A2, we're going to take the total voltage, which is 120 volts. That stays the same through the whole problem. The total resistance, you remember that answer from the previous step? So write that answer in down here. And then when you divide the top number divided by the bottom number, that is going to be your current. And remember, we measure current in amps, or sometimes they call it amperes. And now we finally have the answer to B. All right, a lot of steps involved there, but we have that final answer now. And 7th slide, here's the good news. You will not have a problem like this again. So I can promise you that on the checkup, the self-test, the PACE test, you will not have to do a problem this long and complicated and involved and remember all of these steps. You definitely will have to do several problems similar to the problems at the top of page V. And you should be able to do all of those pretty easily if you remember the magic triangle. Let's see if we remember it. Put the V on the top and then I and R on the bottom. And whatever you're solving for, cover that one up, divide the other two, or if you're solving for the top one, these two are side by side, so you multiply. If you remember that magic triangle, you should have no problem on the checkup and the self-test and the PACE test. All right, I hope you do well.